3.3 Linear Functions. First we have y equals mx plus b is a linear equation. This is our slope-intercept form of the linear equation. If we have f of x equals mx plus b, this is a linear function. Remember that f of x and y are the same thing. So wherever you see f of x, you could replace it with y. If they ask you to write it as a function, you will replace the y with f of x. So the directions that say graph the linear equation, y equals 2x plus 1, is the same as saying graph the linear function, f of x equals 2x plus 1. You're going to do the same work for each one. We have the equation 3x plus 5y equals 10. This is in standard form where you have ax plus by equals some constant. Right? That's standard form. They ask us to write it in slope-intercept form and in function notation. So first we will go to slope-intercept form. It's just going to be some algebra. I'll rewrite it so we have some space, but we're just going to manipulate it and isolate the y to get slope-intercept form. So first we'll subtract 3x from both sides. When you subtract it here, it's gone. Divide by 5 all the way across each term. So we get y equals 2. You can pull your coefficient away, minus 3/5 x. If we want to switch the order, we can. Y equals negative 3/5 x plus 2. This is slope-intercept form. It has the y isolated. That's the piece that's important for slope-intercept form. Remember that f of x and y are the same thing. So we can rewrite this as a function just by writing f of x is negative 3/5 x plus 2. The next problem asks us to graph the linear function by finding the x and y intercepts. And here is our equation or function. And remember to do that, you plug in zeros. So if we want the x-intercept, we plug 0 into y. So 2x plus 4 times 0 equals 8. This is gone. 2x equals 8. Divide by 2, x equals 4. So we have 4, 0. 1, 2, 3, 4. 0. And then switch and put 0 into the other one. So put the 0 into the x, and so we have 2 times 0 plus 4y equals 8. This piece cancels. 4y equals 8. Divide by 4, so you get y equals 2. So 0, 2, don't go over, go up 2. Then we'll just connect the dots to draw our line. The next part of the question asks us to write this equation using function notation. So we need to change to slope-intercept form. We're going to isolate the y. So I'm going to subtract the 2x from both sides. I'm going to slide back this way a little bit just so I'll have enough room. Right, I'm subtracting 2x, so this is gone. 8 minus 2x. I'm going to divide everything by 4. So I get y equals 2 minus, you can go ahead and reduce there, will be a half. X, if you want to switch the order, you can. Negative 1/2 x plus 2. And now to put it in function notation, we just switch the y over to f of x equals negative 1/2 x plus 2. Next, we'll take a quick look at slope. Slope is a number which represents the steepness of the line. It is a ratio of the vertical change to the horizontal change, or the rise over the run, we often use the letter M for slope. If we already have a picture of the line, we can count between 2 points to find the slope. So we could start at either point. We want one of the points that hits at the corner, so we're moving with whole numbers. If we start here and we move to the other point, so we will just count, and we're going to count our vertical movement. Don't count where you start, count the next one. So 1, 2, 3, 4. We're going up, so it'll be a positive 4. That's your vertical change or your rise. From there, to get to the point, we will go across. To the right will be positive, to the left would be negative. 1, 2, 3, 4, 5, 6. So for every 4 units it goes up, it goes across 6. We can reduce it to go into 4 2 times, 2 into 6 will go 3. So for every 2 unit it goes up, it goes over 3, and you're going to hit the line again. That slope will be the same for the entire line. This picture is an example of a line with a positive slope. A line with a positive slope goes up as you go to the right. Our next picture gives us an example of a line with a negative slope. Notice it goes down as you go toward the right. We always talk about toward the right. So it goes down as we go to the right. It is a negative slope. We can count on this one from our points. You can start at either one. Right? If I start here to move to this one, I'm going down 1. Down is negative. Across to the right, 1, 2, 3, 4. So a negative 1/4 or negative 1/4. If I wanted to count the other way, I would have started here. I would have gone up 1. But then I would have had to go to the left 4. Remember, if you only have one negative, it doesn't matter where it is on there. These are the same. So you could go either way. We'll look next at our special lines. First, our horizontal line. And if we made a couple of points on there that hit at the corners, you can put any ones you want. Say I had these 2 points on there. If I tried to count, if I start here, my vertical movement to get to the other one, I'm already lined up with it. So I'm not going to move any. Right? For the particular points I chose, I'm going to move 1, 2, 3 to the right. But 0 divided by anything gives us 0. So it doesn't matter what you put on the denominator. It doesn't matter what your points are. You're going to get 0 over something is 0. So all horizontal lines will have a 0 slope. Next, we'll look at our other special line, a vertical line. And let's put some points on there and we'll count and see what happens. So if I put those 2, I can start at either one. So if I start down here, and my slope is vertical over horizontal movement. All right, I do have vertical movement on this. I have 2. Right, but how much do I move across? I don't. I'm already lined up. So what happens when you get a 0 in the denominator? It is undefined. So it wouldn't matter what your numerator is, so it doesn't matter where your points are, because you're going to get a 0 in the denominator every time. So this will be undefined. Vertical line has an undefined slope. Be careful about the term no slope. Some books use the term no slope. No slope is confusing, whether they mean a horizontal line with 0 slope or whether they mean a vertical line with an undefined slope. So stay away from that term. Stick with 0 and undefined for slope. So we have 4 cases for slope. A positive line, or a line with a positive slope, will go up as it goes toward the right. It can be steeper or flatter, but it's going to go up as it goes to the right. A negative slope will go down as it goes toward the right. A zero slope is on a horizontal line, and a vertical line has an undefined slope. A lot of times you can answer questions just by knowing those four general cases.